Hello and welcome to pH Chemistry. Today's explainer is Le Chatelier's principle. Disturb an equilibrium and it shifts to oppose the change. By the end of this video, you'll know how concentration, pressure and temperature each affect the equilibrium position. If a system at equilibrium is disturbed by a change in concentration, pressure or temperature, the equilibrium shifts in the direction that opposes the change. So increase the concentration of one side and it shifts away from it. Increase the pressure, it shifts to the side with fewer moles of gas. Increase the temperature, it shifts in the endothermic direction. Three things. 1. Opposing the change is the key idea. 2. Pressure only affects equilibria with different numbers of gas moles on each side. And 3. Catalysts don't shift the equilibrium, they just get there faster. Common slip. Applying pressure rules to a reaction where moles of gas are equal on both sides. If there are 2 moles on each side, pressure changes have no effect on the equilibrium position. A quick example, N2 plus 3H2 goes to 2NH3, exothermic forward. So higher pressure goes to the side with fewer moles, 2 instead of 4, which means more NH3. Higher temperature moves to the endothermic direction, so it reverse, and less NH3. And there's a real industrial trade-off in the Haber process. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus mastery workbooks across physics, maths, chemistry and biology. One for every higher topic in each of the subjects, with every answer fully worked and every common slip flagged. Simple explanations, serious results. See you next video.